Hello everyone and welcome to this demo that is about a ProM plugin for finding the causal relationships among the process features. The input of this plugin is an event log, process model, and the replay results. Let's run it. The name of the plugin is root cause analysis using structural equation model. As you can see, there is two parts, the right part and the left part. The right part is about the setting and the left part is about the results. The right part includes three type of data extraction. That in first one, the target feature is a trace attribute. In the second one, the target feature is an event attribute. And in the third one, the target feature is a choice place. It's the choice that happened in one of the choice places. And the last tab is about the setting for finding the causal relationships. Let's start with a very simple example. We are interested to see what causes the process workload to be higher or lower. For that, I'm going to take a look at, for example, deviation as a trace attribute. Okay, where is it? Yeah. And also, I'm going to look at these two events, the number of active events with these two activity names. For that, I need to select number of active events. And for time unit, I'm going to use day. As time window, I'm going to use 1 day. For offset, the default is 0, and I'm okay with it. Let's create the table. It's gonna look like this. Now let's go and do the search and see how the causal relationships are among these features. If you know the causal relationships, go ahead and start with an empty graph and edit it. But if you are like me and you don't know them, you need to use a search algorithm. For that, first of all, you need to select the type of features. Here we had continuous features, so the default selection were correct. If we wanted to do the search, we can see that some null values has been detected in the data, and this algorithm doesn't like them, so let's remove them. Okay, the causal relationships that have been found in this data has been like this by the search algorithm. And as you can see, this search algorithm, or all the search algorithms in general, they are not that good in finding the directions. So we're going to edit this graph to adapt to a causal structures by editing the directions. For that, I'm going to add directions. So I need to use the default selection here for the add required directions. No need to change. For example, I imagine that deviation causes process workload. And as this activity happened before T null to then this direction, also this one, and this one. Let's see if the knowledge graph is as I like. Yes, it is. And let's generate the final graph. Okay, that's nice. And now let's do the estimation. As you can see, some numbers has been added as weights to the ages. And now these numbers, how we can interpret them, these weights, age weights. Let's click on one of the vertices. What we can see here is some statistical information about the distribution of values in feature deviation. And also, if you look at the fourth line, you can see an equation. This equation shows how changing the value of deviation gonna affect the value of process workload. Here, we assume that the causal structure that I selected, the direction that I add to the sort of causal relationships statistically that has been statistically found are correct. So if you choose another directions, you will find another values. Let's assume that these directions are correct. In this way, we can interpret this equation as if we increase the deviation by 1 unit, then the amount of process workload gonna increase by 3.8 units. The rest is sort of the same, but for the discrete values here, you're gonna have a table that shows the when you click on any vertex, you're gonna have a table that shows the interventional distribution by setting the value of that vertex to, or the feature corresponding to that vertex to one of its values. And that's it. I hope that you enjoyed it and you can use this plugin. And please let me know about the feedbacks. Thank you for your attention and have a nice time.